So here is an idea, all right? So we define ideas using a class. Now, I'm using the word idea as a synonym for the word object. I know they're not synonyms, but I'm using them as synonyms. Why? Because when you have a dog, when you think of a dog, when you write a class for a dog, like we did earlier with the dog class, and how we did for the other 9 animals, is what we do is we actually describe an idea about this object, right? We don't actually get a dog and like shove it into the computer. Don't do that. That's mean. But what we do is we have an idea of what a dog is. And based on that idea, you're able to describe the dog. You're able to create the class. You're able to say it has this data and it has these functionalities. So everything is based on an idea that you have of the object. If I ask you to make a class that represents a dog, and then I ask all of you to do that, all of your classes will look slightly different. There will be a lot of things in common, which is good, right? If our ideas of a dog are completely different, then we cannot even talk about dogs. How could we talk about dogs if our ideas of them are completely different? So there will be a lot of overlap, but even then, there will be a little bit of a variation, because your idea of a dog might be different. Maybe you're thinking of a pet. Another person is thinking of a guard to a farm, and so on, right? So here, we define an idea, an object, using a class through data members and functionalities. Now, what's interesting is that some of these ideas that we have, they overlap. So the dog idea and the cat idea, even though they're 2 separate objects, even though they're 2 separate ideas, there's a lot about these 2 ideas that are overlapping, that have in common. So you might say, well, they're both what? They're both able to run, they both breathe, they both have a heart, they have an age, they have a weight, they're both pets. There's all these things, right, that they overlap in. They're completely different. They're 2 separate objects, 2 separate ideas, but there's just so much about the 2 that is in common, that it's the same. They both have hair. Okay, there's some dogs and cats that don't have hair, but you know what I mean, right? There's a lot of things about these 2 that overlaps. So here's an idea. What if we could define the stuff that overlaps among ideas first? So we describe everything that overlaps on all the ideas that we have. Then the difference of those ideas, we define them later, separately. Okay, so to understand this, let's look at some examples. So here I have a dog and a cat, right? Here, a dog and a cat. This was supposed to be animated. Wonder what happened. But anyways, here's a dog and here's a cat, right? You can describe the idea of a dog, kind of as we did earlier. Age, weight, has a heart, it can breathe, it can eat, and it can bark. And then you go and you look at the cat, and then you say, well, the cat also has an age, a weight, a heart, it can breathe, it can eat, and it makes hairballs, okay? There's a lot of overlap in these 2 ideas. What is the overlap? The age, the weight, the heart, it can breathe, and it can eat. Those 5 things in this idea of a dog and in this idea of a cat, they overlap. So what can I call the overlap within the context of a dog and a cat? Well, I can call it an animal, right? There's more things you can call it. You can call it a living organism if you wanted to. That's another way to describe the overlap. A living organism, you could say, well, that's something that has an age, weight. Okay, maybe not all living organisms have a heart. Okay, we won't make biologists angry, but let's just say, they do. So all have a heart, they breathe and they eat. Okay, maybe they don't all breathe and they don't eat how we conventionally think of eating, but you get the point. Another way would be a pet, right? Instead of animal, I could say, well, they're both pets. The idea of a dog that overlaps with the idea of a cat is something that I can describe as pet, right? And so on. A mammal would be another one. And I'm sure there's a bunch more that we can think of. Well, here's another one. We have a square and a circle, right? So square is this thing that has 4 sides. They're all the same, right? And in the square, you can give characteristics of the square, which is it has a perimeter, it has an area, right? Those are some characteristics of the square. Then you go look at a circle, and the circle is this thing that has infinitely many sides. It has a radius, and it also has a perimeter, and it has an area. So they overlap in the idea that they both have perimeters and they both have areas. Well, how can we describe that? that overlapping idea? Well, we can describe it as a shape. We can say all shapes have a perimeter and an area. So the overlapping idea between square and circle, it's the shape. Okay, here's another one. We have a car and we have a bus. The car is something that moves very fast, relatively speaking to humans. It gets you from point A to point B, and let's just say that's it, right? And a bus is something that's also relatively fast to humans, and you can get a bunch of people from point A to point B. So there's two things that these two overlap. The fact that they go from point A to point B at a relatively high speed, and they take people from point A to point B. What do we call that? We can call that a vehicle, right? So the overlapping idea will be that it's a vehicle. Here's another one. We have a Walmart and Best Buy, and we're not getting ad revenue for using them. All right, so we have Walmart and we have Best Buy, okay? Walmart is a place you go in and you look for things that you want to buy. You can see them, you grab them, you go to the cashier, and the cashier charges you an amount of money. You pay them and you take those items. Best Buy, similar thing, but it's all related to electronics, right? So what is the thing that they overlap? The fact that you can go into this establishment, you can get items, you go to a cashier, and then that cashier charges you money for it, and you pay for it, and you take those items home. What can we call that? That overlapping idea. We call that a store. All right, so here's another one. Chrome and Firefox. Chrome is this thing made by Google, which it allows you to go into a website, get the contents of a website, and display it. It lets you log in with your Google account, and it synchronizes the history and everything. Then you go and you look at Firefox, and Firefox is this program that is designed and developed by Mozilla, and they also let you go into a website and display its contents. And I also believe they let you log in with your Google account, and I don't know if they have synchronization of browser among devices. But there's an overlapping idea. The overlapping idea is that we can go to a website and display those contents. What do we call that? We call that a browser, right? I hope you're starting to see the pattern here, right? So here's a table. A table is something that you have on your dining room where you can put, silverware, you can put food, you can put whatever that you're going to eat, you can put it on top of the table, right? And here you have a desk, which is a thing that you have maybe at your office, and you're able to put your keyboard, your mouse, your computer, your pen, pencil, notebook, right? So what's something that they both have in common? Then you can put things on top of them. So what do we call that? Well, we call that a surface. Okay, great. So let's go to another one. Here's a hammer. The hammer is something that allows you to do this thing that would be difficult to do otherwise if you didn't have it, like putting a nail onto the wall, right? Without the hammer, you wouldn't be able to do it. It would kind of hurt if you were to punch it, right? Here you have a clamp. It's something that would allow you to put something in a very fixed position that if you didn't have this clamp, it would be very difficult to keep that thing in that same position. So the idea is that these two allow you to do things that otherwise you couldn't do by yourself in a humanly possible way. What do we call those? We call those tools, right? So that's where they overlap. And the last example is here we have Earth, a place where people live, and there's a bunch of rocks and elements and water and living organisms and people talking about programming and inheritance. And then on the right, we have Mars, which is a place that apparently maybe has no living organisms, but it has a bunch of rocks, it has water, and a bunch of gases in it. What is the thing they overlap? That they're both massive. They both have a bunch of different elements and rocks and water and gas and all these things. So what do we call that thing? Gravity would be another one. They both have a gravity. So we call these things a planet. I hope that with all these examples, you're starting to see a pattern here, that you're starting to see what we're actually doing. And what I want you to realize is that I want you to notice that everything about the idea in the upper level is 100% relevant to the ideas in the lower levels, which means everything related to planet, however you can describe a planet, just a planet in general, every description that you have of a planet, whether that is data or functionalities, they all apply to Earth and they all applies to Mars, right? Everything. If there is something that doesn't apply to Earth, then our definition of planet is either wrong or Earth is not a planet. All right, there's something weird going on there. If we look at, let's look at another one, the browser. Everything that a browser can do, display contents on the website, and all these other things, everything that a browser can do, how we define a browser, everything about it has to be fit also to Chrome, and it also has to fit Firefox. So everything that I have relevant on the top level is relevant to the lower level, 100% of it, right? Everything relevant to a vehicle is relevant to car and bus. Everything relevant to a shape is relevant to square and circle, and so on, right? Okay, what do we call this? We call this inheritance, right? This is where inheritance comes in. And basically this bullet right here is the reverse of this bullet, right? And it's the lower level ideas inherit all descriptions of upper level ideas. So everything at the bottom level has everything that the upper level has described. So the upper level describe, a big massive thing that has rocks and gases and all these things, and then you say, okay, well, everything that Earth is going to be whatever this is plus something else, but it's going to be 100% relevant of what planet is onto Earth, and same thing with all the other examples. So the lower level ideas inherit every description, every data member and functionality of upper level ideas, everything, okay? As you can see, we can use this for our repeated members. We can say, hey, all the repetition, is where the ideas overlap. Everything that overlaps, that's a repetition. Can we give the repetition a name and describe it as a unique idea, as a unique object? And the answer is, for the most part, we can.